Hey guys, so in the lab for a portion of class today, I'm going to keep you with me for the lab intro and how we make good observations on things, and I'll have somebody just live stream that so you can take the notes. But so you guys can get a good look at what's going on with the experiment. Just like last time, I'm going to demo the stuff here for you so you can see what we are working with. All right, so the lab we're working on is the one you see here, copper extraction lab. And the goal of this one here is we want to run a series of reactions where you guys get to see all the different chemical changes and signs of a chemical reaction. But the real goal is that we want to take this stuff right here, right, this copper 2 nitrate, and believe it or not, we want to rip the copper metal out of this. Right now it's living as an ion. We want to extract the copper, all right, from this, and so you get to see the copper metal. So I'm going to walk you through the procedure, all right, so you can see what everybody was doing. All right, so the first step, it said we want to get a 150 ml beaker, right, and make a water bath. All right, so making a water bath means just setting up your ring stand and getting some water boiling for a later step. So I'm going to run up and I'm going to turn the gas on so we can do that. All right, and then I'm going to show you the setup for that. All right, so we've got our gas on. I'm going to go in my drawer. I'm going to get out my 100 ml beaker. All right, and I'm going to fill it halfway. Right, and then what I'm going to do is I'm going to set up our ring stand with an iron ring on the top. So that we can get this water boiling for what we're doing. So I'm going to use my wire gauze, set that up there, get my beaker up there, make sure it's nice and sturdy, go in my drawer, take out my Bunsen burner, hook that guy up, get in here, take out my striker, if I can find it. Take my striker, turn on my gas, one over here, light it. Got my burner going. I'm just gonna set that underneath. Right. And I'm gonna let that boil, right, so that that water can use for indirect heat in a later step. Then, while it's heating up, right, I'm gonna go into my drawer and I'm gonna get out my test tube rack. Right. Then I'm gonna take out a test tube and I'm gonna put 3 red marks on it. Right, and those 3 red marks are just for knowing how much of my substance to put in. So the first thing it says there is add 1 molar copper 2 nitrate to the first mark on the test tube. Right, so you guys would go over to the middle counter, you would get a pipette of the copper 2 nitrate, and we're going to put that in till the first line. Right, I'm going to set that off to the side. Then it says add 1.5 molar sodium hydroxide to the second mark and then mix with the stir rod. All right, and then it says rinse the stir rod to touch the bottom to see if any heat has been absorbed or released. All right, so I'm going to go over to the middle counter, and I'm going to get the sodium hydroxide. And the sodium hydroxide is a clear, colorless liquid, and the copper 2 nitrate is a clear blue liquid. So I'm going to add the sodium hydroxide to the second line. All right, so if I bring that nice and close, you guys can make an observation here. You can see we've got some liquid down here, and we've got this blue, gooey, gel-like solid above it. All right, so you want to observe the solid in your table. And remember, you always want to tell me if there's color to the solid and what is the texture. And then you want to observe the liquid. All right, and with the liquid, you want to tell me, is it clear or is it cloudy? And is it colored or does it not have color? Is it colorless? And remember, clear just means you can see through. All right, so there's your first reaction. You guys should be filling in the portion of your table. That's this line right here. All right, your very top line. All right, so you guys can fill that in. While you're doing that, I'm going to go ahead with my glass stir rod. And I'm going to give this guy a stir, like it said. See what happens. And then it said to check the thing for heat. I can tell you no heat being given off of that on the bottom. All right, then we're into step 5, and it says put the test tube in the water bath set up in step 1, which is now boiling, and it says heat the test tube for 4 minutes. All right, fill up a 400 milliliter beaker with tap water and remove. So I'm going to take this guy out of here. I'm going to put him in there, and what we're doing is we are indirectly heating that substance, right? We're letting the boiling water transfer the heat from it into the substance inside the test tube. All right, so what we're looking at there is an endothermic reaction, and we're supposed, right, to be, when we heat up that copper 2 hydroxide, it's supposed to become copper 2 oxide and water, and if that change occurs, we should see some signs of a reaction. All right, so in the meantime, it told us, right, that we should set up a 400 milliliter beaker with tap water to cool the thing off. And so if we do that, I'll go into my drawer. Getting out my 400 ml beaker. Fill that up with some water. Just regular old fashioned. All right, let that settle in. All right, we still have about 2 minutes of heating on that front, so we'll let that go for 2 more minutes. All right, and then after 2 minutes, what we'll do is we'll make observations on it once we cool it, and then we'll advance on into step 6. So it's worth noting that when we usually will do something like this, right, where I have like a timed heating like that, I'll do it ahead of time for you, all right, and well, kind of fast forward so that you just don't have to like sit and watch. But because we're doing a reaction and observing, then doing another reaction and observing and doing another reaction and observing, I wasn't able to do that for you guys today. But anytime we're doing something where I'm just going to heat the thing for 20 minutes and then we're observing it when it's done and we aren't doing any additional things to it, I'll have that be a lot faster for you. So I apologize. You guys have to sit and watch for a couple minutes, but you will be getting the true lab experience today that everybody else is. All right, so we still got about 60 seconds on that. Hitting the home stretch. All right, while that is going on, all right, I'm going to show you a piece that we're going to need for a later part. This is a piece of aluminum wire, which we're going to use, all right, for a later part of the experiment. All right, aluminum wire, very soft, very flexible, all right, can be bent, all right, but that's going to be one of our reactants in steps 4 and 5. I'm going to wash off my stir rod while we're doing this. Just taking care of some things while we're using that 4 minutes. Right, I don't need these 2 pipettes any longer, so I'm going to go ahead and throw those away in the red trash cans. All right, and we're at our 4 minutes. So now what I'm going to do is I'm going to move that test tube out of my hot water bath and into this normal water just for cooling. So I'm going to use my test tube holders to do that. Go over here, grab this guy, bring my beaker up. That way we don't have to move the glass a far distance. All right, going to set that down. I'm going to tell Siri, set a timer for 2 minutes, please.
Okay, 2
All
minutes.
right, so we're going to let that guy cool for 2 minutes. And then when he's done cooling, we're going to observe. So we're done with our burner. So I can shut the burner down. Right, but obviously that's still a little bit hot, right? And there's no reason for us to be touching that hot metal if we don't have to. So we'll just let that sit up there and let it cool for a little bit. But the burner itself, it never really gets that hot. So I can take that out. As long as I hold things by the bottom, I can go ahead and I can put my burner away. I don't know if you can see the screen of a screen. Oh, there you go. Thanks. We'll show you the countdown. So we got about a minute to go. And then after that minute, what we're going to do, right, is we're going to make our observations and we're going to fill in this second line, right, of the data table. And when we fill in that second line of the data table, if you see a solid, color and texture. If you see a liquid, clear, cloudy, colorless. All right. And if we see bubbles for a gas, we'll go ahead and do that. So we've got some guys coming in for review. Don't freak out. You guys can just grab a seat. All right, I'll be done with this in like 2 or 3 minutes. And so we got about 30 more seconds with that to cool. Give you a peek at what it looks like. This here is what you're going to be observing. Okay. Right. And our alarm was going to go off. All right. So you're going to go ahead and you're going to make observations on this guy. If I hold it back, it's probably easier to see the color. It looks like you have 2 different solids in there. One looks like it's black. One looks kind of like a pale blue. And then it looks like you have a liquid above it that is clear and pale blue. So I would fill those in for your observations. All right, so now that we've got that, we can move our water out of the way. We can bring back our test tube rack. And we're ready to move on to the step where we're going to add the hydrochloric acid. So we'll get the hydrochloric acid. And what I'm going to do is I'm going to add hydrochloric acid to this guy till that solid in there goes away. So I'm going to add this pipette, set that down, and then I'm going to go over here and grab my stir rod, and I'm going to give this a stir till we can get that black and blue solid to disappear. So I got that in there. Not quite gone. So I'm going to add a little bit more. Giving it a good stir here. Okay. All right. And now we've had that reaction. All right. So no more solid left in here because we purposely made that go away. So now you're observing this liquid. All right. So talk to me about color. Talk to me about clear or cloudy. All right. So fill that in while we move that over here. And the last step of the experiment is we're going to take this piece of aluminum, right, and we're just going to put the aluminum wire into the blue clear liquid. All right, now this reaction takes a little bit to occur. There's two reactions going on. The aluminum's reacting with the copper 2 chloride, which is the blue stuff that's in there, but there's also leftover hydrochloric acid, and the aluminum's reacting with that as well. Right, so I'm going to slide that in a little closer, right, and I'm going to move that so that you can see. Okay, so make some observations on that guy. And then this one takes about 10 minutes to occur. So you can make one observation right now. You see some bubbles forming on that wire. All right, the other one's going to take a little bit longer. So I'm going to set a timer for 10 minutes. All right, now let that go. All right, and then when you hear that the buzzer go off here, just make sure, all right, you get a good observation. I'll come back and show it to you. And in the meantime, we'll be doing some test review, which you guys are welcome to listen in on. Set a timer for 10 minutes.
Your timer is set for 10 minutes.
Okay. Get some topics up, let you guys ask some questions. And see how we're doing. Okay. So, topics. Use my laptop to record. All right, talk to me about branches of chem. There are 5. Who can tell me a name on one? Organic, what's it study? Carbon. So organic studies carbon. Organic studies carbon. There's one there. Second one. Inorganic chem, what's it study? All the other elements, the not carbon elements. There's 2. What's the third one? Analytical is 1. What's the analytical study? Identifying compounds, identifying unknowns. That's 3. How about 4th? Physical. What's physical study? Energy. Good. Changing and how it relates to energy. Last one? Biochem. What's biochem study? Chem within living things. All right. Those are your branches of chem. You don't need to know the careers. You just need to know the name of it and what it's done. How about endo versus exothermic, right? What's endothermic talking about? Heat needs to come in for it to occur. Generally, how does it feel if you touch it? Cold. Generally cold, but watch out for phase changes, right? Like solid to liquid, liquid to gas. You have to think, what does it have to do to become the other one? So think, if I want to go from being a gas to being a liquid, what do I have to do as a gas with heat? Like who's hotter, a gas or a liquid? A gas. So if a gas wants to become a liquid, what's it have to do? It has to lose heat. It has to give off heat. If I'm giving off heat, which of those 2 am I? Exothermic, right? So remember, gas is the hottest phase. Liquids are in the middle. Solids are the coldest phase. So if I want to be a solid going to a liquid. I want to melt, right? What do I have to do as a solid? Get heat, right? Solid to a liquid. I'm going from colder to hotter. I have to take in heat, which means I am endothermic. So the phase changes are the tricky ones. You have to think about who is the hot phase, who's the cold phase, and decide what to do. The other ones, honestly, if you touch it, it feels cold, it's endothermic. If you touch it, it feels hot, it's exothermic. Okay. All right. How about signs of a reaction? All those demos I did the other day. All right. There's 5 of those as well. What are they? Production of heat, right? How can I check for production of heat? I could feel it. What else could I do? How do you guys measure heat on a given day? Yeah, I can take a thermometer to see if there's a temperature rise or drop, right? So there's creation of heat. I can do a thermometer or touch it. I heard creation of light. How could I check for creation of light? Yeah, right. Turn the lights out in the room and see if it gets brighter. All right. Change in color. How could we check for that? Just observe it, right? Put a white sheet of paper behind it to see if you see any color change. All right, that's 3. There's 2 more. Formation of a gas. What would you look for? Bubbles if there's a liquid. If it was giving off bubbles as a solid, it'd be tougher to see, right? So usually we put it inside a liquid so we can see those bubbles. All right, that's 4. There's 1 more. Formation of a precipitate. What's a precipitate? Solid. How could I check for that? Yeah, just observe it and see if I see a solid when I pour 2 liquids together. Right, those are your signs of your reaction. All right, how about, talk to me about the scientific method. Where does it start? So it's an observation. What 2 styles of observation can we make? Quantitative and qualitative. Quantitative is number, qualitative is non-number. Okay. All right, so we make our observation, then we advance to what? Yeah, we come up with a hypothesis. What's a hypothesis? Careful with the educated, right? Because you might not have a lot of data. I know that's like the old school. Just say it's an answer to a question. All right, so answer to a question is a hypothesis. All right, so we observe something real quick, and then we come up with an answer to our question. What do we do next? Yeah, we got to test it. What's that thing called that's running in the back right now for my guys at home? An experiment. So we test with an experiment. All right, what's that experiment generate for us? Data, right? We get a bunch of data. When we do that, and what do we have to do with that data? Yeah, we got to analyze it, right? So we do a data analysis. Here's where you get a couple paths. Path 1, not good. My data does not agree with my hypothesis. What do? I go back up here. If I keep getting data that goes against my hypothesis, I got to change my hypothesis. But if my data is good, it keeps agreeing, I get to keep advancing. Where do I go? I get to make a theory which explains why I'm seeing what I'm seeing. All right, so there's kind of the ins and outs of your scientific method. All right, so that was scientific. All right, how about our classes of matter? What are our classes of matter? There are 4. I will give you 1. Element. Compound. Hetero. Homogeneous mixture. All right. Where do I find elements at? Periodic table. So if I give you an example and its name is in 1 box in the periodic table, it's an element. Compounds are 2 elements put together. Right? So lithium would be an element. Lithium oxide, lithium chloride, lithium sulfate, lithium hydride, lithium blah, blah. Anything that's like 2 words, but they both sound like they're coming from the periodic table is a compound. There's exceptions, right? What's water? H2O. So it has a formula, right? If it has a formula, it's also a compound, but there's some everyday stuff that we give common names to. The technical name for water is dihydrogen monoxide, right? We never say that, we just say water. So just be careful. There's a couple that are sneaky with compounds. All right, these guys here, my mixtures, they have everyday names. Doesn't look like the periodic table, right? Coffee, soda, juice, right? Is there a box on the table that says coffee? No. Does it sound like two boxes put together? No. So you know it's not an element or a compound. Now you know it's a mixture. To know if it's homogeneous or heterogeneous, what do you have to know? Yeah, you have to know what it looks like. So if you aren't sure what something looks like, ask. All right, so let's talk about just normal coffee that just has cream in it. Does it look like one thing, or can you see the differences? One thing, which means it's homogeneous, right? So if it looks like one thing, it's homogeneous. Okay. What about birthday cake? Element? No. Compound? No. Right. Mixture? Gotta be. Birthday cake. See the pieces, or it looks like one thing? See the pieces, right? You can tell the difference between like the cake part and the icing part, right? So because I see the pieces, that makes it what? Heterogeneous. Right? How about Gatorade? Right? Element? Yeah. Compound? Yeah. Right? Because there's no boxes from the periodic table on it. Right? Homogeneous or heterogeneous? Homogeneous, right? Looks like one thing. Right? So that'd be a homogeneous mixture. How about nitrogen dioxide? Compound. Why? Two elements sandwiched together, right? So it's two different boxes, but they're put together. Nitrogen has its own box, oxygen, oxide has its own box. Put them together, it's a compound. How about iridium? Element, right? You guys get the hang of how that works. There'll be a big section just on it. It's the name of an element, it's the name of a compound, or it's a mixture, and you just tell me which one. Okay. All right, so those are your classes of matter. How about phases of matter? Right, what are my three? There's four technically, but we focus on three. What are my phases of matter? Solid, liquid, gas. And the fourth one that we don't talk about much is plasma. Like in your head, think for a second about what the particles look like. Those together for a work. Okay, so observation time for you guys. Right, after 10 minutes, this is what that guy looks like. All right, so take a second and you can fill in the boxes on the bottom two rows of your data table because the reactions are happening at the same time. All right, so you can talk about color, you can talk about texture, don't forget to describe the liquid, and I can confirm there are bubbles on that. All right, and then the rest of the time the guys are in the lab, they'll just be working on the lab report. All right, shoot me a parent square or an email if you guys have any questions.